Az Agro Napló a tudatos gazdálkodó állandó partnere.
Distinguished guests, good morning. It is a great pleasure that so many of you followed our 150 years invitation. Today is all about celebration. Celebrating not only BASF's 150th anniversary, but celebrating chemistry as an enabling technology to solve the issues and the challenges of our future. My dream would be, ladies and gentlemen, that you leave our event tonight sharing the same passion for chemistry as we do at BASF. And we will work hard to make that happen today. In order to set the stage, let me show you a little story or tell you a little story from a professor of strategic communication. His name is Professor Simon Sinek. He teaches at Columbia University, and he was reflecting a few years ago what differentiates leaders and leading companies from anyone else. And he uses Apple as an example, Apple the computer company, because everyone understands that they are an end consumer producer. He was asking himself, why is Apple so creative, so innovative, year after year after year? And he figured out that there is a pattern in communication of successful companies or leaders, and he characterized this as the what, the how, and the why. Now every person, every company on this planet knows exactly what they are doing, and that's what usually they tell us first. Some of the companies also know how they do it. Let us call it their unique selling proposition. But very rare of the companies, very few of the companies share with us why they do it, what is their purpose, what is their reason to exist, their reason to be. And Steve Jobs from Apple, this is the story Professor Sinek shared with us, was turning the sequence exactly opposite around. He was obsessed from the idea to create products which are simple to use and beautifully designed. And that's why so many people followed Steve Jobs and Apple, be it as customers or be it as employees, because they shared his vision. Now this is not an Apple show, ladies and gentlemen. You will have figured out this is a BASF event today. Why do I tell you this story? What we learned from Simon Sinek's reflections on Apple and other leading companies was simply that if you want to convince your stakeholders, if you want the people, the general public, your customers to be with you, they need to understand your reason. And BASF has phrased its purpose, its reason to exist in a very short sentence. We create chemistry, ladies and gentlemen. We create chemistry does not only say that we produce chemicals, but we create chemistry says that we are able to connect the dots between society's needs and our innovations. We match our innovations with society's needs. And here you come also into the game, ladies and gentlemen, because you, our stakeholders, the general public, we are also trying to connect the dots with you to get our framework right. Now, let us talk a little bit more about these reflections and trends, and I would like to show you that despite this purpose statement is relatively new, we have been doing this since 150 years already. Let us go back to the 19th century. In the 19th century, it was the age of the dyes. And dyes at that time were very expensive because they have been produced from natural resources. Excuse me, ladies and gentlemen, I need to take a sip of water here. Thank you very much. That's much better. So dyes in the 19th century were very expensive because they were produced from natural resources. So the industry was looking for ways to create synthetic dyes. And this was not so easy at that time. For example, indigo. Indigo is the blue color used today in our blue jeans, but at that time also in soldiers' uniforms or in workers' clothes. And with the Industrial Revolution and the rising need for colorants, the industry was looking for a way to synthetic indigo. And BASF at that time, ladies and gentlemen, invested an incredible amount of 18 million gold marks. This was equivalent to the capital stock of BASF. And after 17 long years of research, 17 years, they found a synthetic way to indigo. Another good example from the early 1920s is the invention of magnetic tapes. And you will ask, ladies and gentlemen, the society's need at that time was not the recording of music. It was the recording of office dictations. It was the first wave of office automation, which was going through the industry. And this is a very good example of co-creation with our stakeholders, our customers, because AEG, a large electrical company at that time, developed the magnetophone hardware, and BASF developed the magnetic tapes. By 1940, when the technology has really substantially improved, we all know that magnetic tapes became the universal recording method for nearly 6 decades. So you've seen that connecting the dots, matching our innovations with society's needs have been always at our heart. Now if we look back at the trends, what is so important, or why is it so important to get the trends? And before I will speak about what are today's challenges and today's trends and how do we match them with our innovations, I would like to share 2 little stories about trends with you. Trends have 2 very unpleasant features, ladies and gentlemen. They are either too slow or they are too fast, at least for us human beings. And 2 metaphors show you very nicely the problematic with slow trends and with fast trends. The metaphor of the frog's dilemma characterizes the problem with the slow trends. And this is the reluctance to change. If a trend is too slow, we as human beings are sometimes reluctant to change. The frog's dilemma goes as follows. We're doing only thought experiments here, ladies and gentlemen, we're not cooking frogs. Very clearly. So, thought experiment, frog's dilemma. You take a pot of hot water and you take a frog and you drop the frog into the hot water. What will happen? The frog feels the stress of the changed environment and will jump out. So he will survive. Now you do the very same experiment, but you take a pot of water at room temperature. And you place the frog in, and since the frog is a cold-blooded animal, he will always adapt to the outside world. So then you start to very gradually increase the temperature, very gradually. So the frog will adapt to the outside temperature, and he will feel more and more convenient, but he might miss a dangerous point when he cannot jump out anymore, and he might be then cooked to death. This is the problem with slow changes, and there are real life examples for it. For example, did you happen to know who invented digital photography? It was a young engineer back in 1975, Mr. Sasson. And Mr. Sasson actually was working for a very famous company at that time, Kodak. And where's Kodak in digital photography today? Back home. What happened? Kodak tried to protect their classical film business. Those of you who are my age don't know what the classical photographic film is. So they made a hell of a lot of money with this business, and they tried to protect their business, and they missed the trend to really develop digital photography. They had 20 years time before the true commercialization of this technology. The problem with fast trends, ladies and gentlemen, is a different one. And this was very nicely described by a professor of risk engineering, also in New York City. His name is Nassim Taleb. And he wrote a world bestseller called The Black Swan. And in this book he gives us the metaphor of a turkey. Let's assume the turkey is born and develops, and the farmer comes every day, he's kept in a nice environment, he's being fed, he grows. So at any point in time, if you would ask the turkey for an extrapolation of his life, you would see that very rosy, linear up. Unfortunately, the poor turkey does not know that there is Christmas or Thanksgiving around. And this is what we call disruptive trends. And we see more and more happening of these disruptive trends in our days. Take, for example, the replacement of Nokia being the #1 mobile phone technology company for more than 10 years. And they were replaced because they did not realize, or they did not make it to create a real smartphone. This is the problem with the trends. Just a few reflections on that. Now, you will ask, what are our trends today? What do we need to innovate for? And I would like to show you a little film which was made with our students or our children. So let's hear what our children have to say about our future.
Minden fejlettebb lesz, sokkal jobb, és sokkal újabb, ami most van. Például, hogy védjük a földet, az már sokkal modernebb lesz.
Nagyon sok új hasznosítás, nagyon sok kölcsönzés, sokat keresett tulajdon.
És erősödni kell. Ez egy cél. És nem sima házak vannak, hanem mindenkinek van egy emelet, amennyiben egy külön szobája. Szóval biztos, hogy lesznek olyan házak, amit csak önmagukat látják el. Olyasmi épületek megjelennek a városokban, mint a Star Wars-ban. Iszonyú gyors kocsikkal.
Elektromos autókkal is kezdődtek.
Repülőautókkal. Addigra már lesznek légpárnás autók.
Egy járművel tudjuk menni levegőben, vízen, úton is. Tehát, hogy minél több dolgot tudjuk felhasználni, és minél jobban szép az a
mindenféle létezetet tudunk tanulni, ezeket tanulni.
Sokkal effektívebb, gyorsabb, és az egész világot átérő kommunikációs állam lesz.
Az ételeket külön kapszuláknál fogják értesíteni, amit egy hálókkal szoroszálló, hogy legyen ez kb. Tényleg egy egész 3 tanácsos vagy 5 tanácsos most fél évnél. Legyetek bátrak! Legyenek továbbra is a személyes kontaktusnál és a személyes kapcsolatok ápolásának az is fontos. Olvassák el, tanulják meg a YouTube-en, most erről lehet történni.
Tanuljuk a múltban.
Ladies and gentlemen, our youngest have already a very clear vision of how the future might look like. But what we are trying to do is we try to look in a future which is a little bit further away, 35 years actually, to the year 2050. 35 years, that does not sound much, right? But think about that already, still 10 years ago, the smartphone was not invented. And the tablet was not invented. So in the last 10 years, our ways of communication have changed dramatically. And now we want to predict the next 35 years, pretty difficult task, ladies and gentlemen. Nevertheless, let's have a look what are the global megatrends, where we can derive from what we need to do. As you see in the chart behind me, we will be 9.6 billion people on this planet, more or less, in the year 2050. This is the current prognosis. Today we are 7.5 billion people, so there will be 2 billion people more on our planet. If you compare this to the year 1950, ladies and gentlemen, you will realize that in the year 1950 we were only 2.5 billion people on this earth. And there's an underlying trend, which you cannot see from this chart. That is, in the year 1950, most of the people were living at the countryside. Today, around about 55% of the population lives in cities, and it is expected that by the year 2050, 70% of the global population will be living in cities. So there are major questions arising from this megatrend. And this is, how will these cities look like? You see a nice picture of Hong Kong behind me. Where will the energy come from, these megacities? And most important, will we be able to supply sufficient food and water for those 9.6 billion people, to have them live in peace together? And what I omitted in my first statement to tell you, our purpose is actually a little bit longer, summarizing these megatrends in a very nice statement. It actually reads, we create chemistry for a sustainable future. So sustainability, ladies and gentlemen, has obviously become the key challenge of our generation. And I would like to show you how we match that with our innovations and where we put our focus on, our research focus on, to match these challenges of the future. In order to do so, we have structured our research areas in 3 main topics: food and nutrition, resources, environment and climate, and quality of life. And I will be commenting on 2, food and nutrition and resources environment. Let's move into food and nutrition. With this megatrend, which I told you, you can easily calculate that we will be 80 million people more each year on our planet. That means 8 times hungry every year. So we need sufficient food for that, for those people. However, the size of our arable land is not growing. That means we need to increase the yield per hectare of arable land. And fortunately, with modern farming technology, with the right methods of irrigation, with the right fertilization, and with, for example, crop protection products from BASF, we're able to substantially increase the yield per hectare of farmland. Take another number, the supply of clean water. Today, 2.5 billion people have no access to clean water. Remember, this was the population, the global population of the year 1950. And when we speak here about environment, then in Europe we are living kind of on a green island. Because environmental protection has gained a very high importance in Europe already. But if you imagine that 80% of the urban wastewaters are released without being treated into rivers, lakes, and the sea. Also for this, ladies and gentlemen, if you compare other regions to Europe, there is a solution, and chemistry can work as an enabling technology here. For example, BASF provides materials and solutions for seawater desalination. In Europe, we are in the very lucky situation that we have a lot of mountainous areas, we have a lot of forest retreat areas, and we have a lot of rivers and lakes where we can gain fresh water. This is not the case for every region in this world. So some regions need to desalinate seawater. For this, we have products in place. Or take sewage treatment with our multi-bore membranes, as I've shown in this picture. Let's move on to the next topic, resources, environment, and climate. The picture I'm showing you, ladies and gentlemen, is a picture where I have been living personally the last 4 years before moving to Budapest, to beautiful Budapest. Some people claim at times we have bad air quality in Budapest. I can tell you, perception is very relative. If you have lived in an area in Asia, where I've been living, where the average air quality index is 250, while our alarm level in Europe is only 50. Air pollution is a major impact, especially in Asia, and we know where this is coming from. Because Asia is mostly fired by coal, and environmental protection has not yet gained the importance as it has in Europe. Also here, BASF has solutions in place, and chemistry can work as an enabling technology. For example, with our exhaust gas treatment products. Or did you happen to know that BASF is one of the largest global catalyst, automotive catalyst producers? So there are solutions which can be solved by chemistry. There's an underlying effect, ladies and gentlemen, under the air pollution, and this is less visible. And this is the depletion of our fossil resources. And I would like to give a little story or share a metaphor with you which is demonstrating this. Let's assume you were invited over at a friend's place. And this is a good friend, and it's his birthday, so you select a very rare, nice bottle of wine, an expensive one. And once you arrive at your friend's place, he welcomes you, takes you to the kitchen, uncorks the bottle of wine, and pours 2/3 of the wine into the sink. You would not be amused, I think. This is, ladies and gentlemen, what we do every day when we drive conventional cars. Because the classical combustion engine has an energy conversion efficiency of around about 30%. If we compare that to an electrical engine, this has an energy conversion efficiency of 95%. So you will ask, why don't we all drive electric cars? Very simple. Because today's battery technology, today's methods for storing energy are not yet as developed as we need them. Fortunately, also here, chemistry can work as an enabling technology, and BASF has become one of the largest players in developing new battery materials to get a higher energy density into our batteries. But BASF is not only active in this, chemistry is also working with a lot of innovations for modern urban mobility, and we're very happy to explore this in our automotive solutions corner in the afternoon or in the lunch break. My colleagues will guide you through that. So you've seen, ladies and gentlemen, that automotive consumption of primary fossil resources is has a major impact. The other major impact to the consumption of fossil resources worldwide is heating and cooling our houses. Round about 30% of the global demand for primary fossil resources is going into automotive, 30% is going into heating and cooling our houses. Now BASF has showcased in a renovation project with houses from the 1950s, you see one of these houses behind me, that we can reduce the primary energy consumption by 90%. Let me give you an example. If you own an apartment of 100 square meters, a classical apartment, with normal available technology, you would consume between 1,500 and 2,000 liters of heating oil every year. And BASF has shown that you can cope with less than 200. And this technology, ladies and gentlemen, is already available. Chemistry is making this possible. Compared to the electromobility, where we still need to put research in. The technology for reduction of primary fossil resources in heating and cooling our houses is available. Now you see that innovation is very close to our heart. And so BASF invests every year about 1.9 billion euros into R&D. We employ 10% of our people in research and development. This is approximately 11,000 people. And we have several hundred university corporations running globally. With this, we are clearly the innovation leader in the chemical industry globally. However, ladies and gentlemen, speaking about innovation, we also need the right framework. And this is where you all, our stakeholders, and the general public comes into play. Now, what is very important for a framework is twofold. We need, on the one hand, the right legislation, on the other hand, the right education. And let me demonstrate that. The British astrophysicist Stephen Hawking cited once, when he was asked about the public opinion of science and technology, he cited the current public opinion towards science and technology is controversial. On the one hand, the public takes for granted the improvements which are coming all from improvements in living standards, which are all coming from science and technology. But on the other hand, they don't trust science and technology because they do not understand it. And how true this is, I want to demonstrate you on the following test poll, which has been carried out in the late 1990s in France. The question to the people on the street was, shall the use of dihydrogen monoxide be banned in the European Union, yes or no? And you see the result, ladies and gentlemen. 75% of the people said, yes, ban it. Dihydrogen monoxide, ladies and gentlemen, for the chemical less educated here, is just water. It's the chemical name for water. You see how easily the general public, if not educated in terms of chemical nomenclature, can be misguided. And the same happens actually with ingredient lists. How do you feel if you see such an ingredient list today? We all feel, oh, I cannot really read these names, but there's a lot of chemistry in there, right? So, cannot be good. The less, the better. This is the ingredient list, the chemical ingredient list, ladies and gentlemen, of an all-natural, biological grown egg. Because the world around us is chemistry. It's all chemistry. There's not the natural world and then there's chemistry. No, it's all chemistry. If we talk about our material world, it's about chemistry. Now what we observe, especially in the countries of Europe, ladies and gentlemen, is that the legislation is more following public fears than a balanced, scientifically based risk assessment approach. This is why BASF has sent a letter together with 11 other R&D heavy companies to the European Commission and its President, Mr. Juncker, to establish the innovation principle besides the precautionary principle. Currently we have the precautionary principle established in the Lisbon Treaty as a rule or a guideline for lawmaking. if it comes to judging science and technology. BASF proposes to establish the innovation principle alongside the precautionary principle. And what does the innovation principle say? It says not more than whenever it comes to legislation, to lawmaking, the impact of this new legislation on innovation and therefore on economic growth and therefore on social stability should be very carefully analyzed, together with, of course, its impact on environment and health. This is clear. But we need to come away from a fear-based legislation to a risk-based legislation which is done and carried out by scientists. I give you a very practical example, ladies and gentlemen. If you go afterwards to the coffee break and you would eat, let's assume you would eat 3 bananas, this is approximately a kilo, I would assume, 3 bananas in a row, then you exceed the limit of formaldehyde set by the European Union. This is coming out of the precautionary principle legislation. So we need to make that reasonable again. Because what we see is that we leave most of the innovation playground today to other continents, to Asia and to the US. If you ask someone on the street about biotechnology today, they say, go away, Jesus Christ, this is dangerous. If you ask someone about nanotechnology today, they say the same. If you sit today on a beach, ladies and gentlemen, on a beach, then you are surrounded by nanotechnology, because the small particles in the sand, the small abrasion, they are nanoparticles. And there are dangerous ones, and there are less dangerous ones. But this needs to be scientifically analyzed and not just following some fears created by some stakeholder groups. Very important. What we at BASF do is educating our youngest. We employ the kids lab or students labs in 30 countries of this world, also in Hungary. Every year, 85,000 students are given the opportunity to explore the fascinating world of chemistry and science and technology in these kids labs. And in Hungary, for example, in the last 3 years, 10,000 kids had the opportunity to join our kids labs. But we also carry out student competitions, like chain reaction 2 years ago. This was a big success in Hungary. And we're very proud to have a new competition in place, which is Future Heroes. And we will be awarding the awards for the winners already today. Ladies and gentlemen, one last remark on education. Education cannot be on the shoulders of companies alone. There needs to be the right environment, and this is the second topic besides the legislation. There needs to be the right environment, the right school education, the right high school education, in order to prepare our children to be able to cope with the challenges of the future. And in that respect, I'm very happy that today Professor Parinkosh and Professor Leite join us, who will be speaking later about innovation and about education. A very important topic which I have realized, the Hungarian government has also realized, and many governments across Europe have realized this. We need to prepare our children in a different skill set than this was maybe done 30 years ago when we went to school. Let me wrap it up, ladies and gentlemen. I think I could show you that chemistry is really an enabling technology. Chemistry is able to solve the challenges of the future. It has been doing so for the past 150 years, and it will be doing in the future. Whenever it comes to our material world, it's about chemistry. Second, I hope I could show you that BASF is, with its R&D landscape, well prepared to tackle these challenges of the future. And we need you all, our stakeholders, to get the framework right. So let us create chemistry together. I thank you very much for your attention.